Hello, Hopewell. This is Mr. Steinberg. This is our e-learning day number 5. We're beginning chapter 9, which deals with trigonometry. Trigonometry just means triangle measurement study. So we are going to be looking at right triangles specifically at the first part of this chapter. In order to be successful in these units, I've actually posted a video that says it's lesson or section 0 with some prerequisite skills. I assume you know a lot of this stuff at the very beginning, but some of it might be new to you, so of course take your time, ask questions if you need to, watch the videos more than once if you also need to. Here's our warm-up. Let's get started. By the way, our objective for today, I want you to use the Pythagorean Theorem and some beginning trigonometry to find lengths and ratios of right triangles. So here we have a picture of a right triangle. It's marked with one right angle. We have two legs and a hypotenuse. The hypotenuse is always across from your 90-degree angle, and the legs are the two sides that make up your 90-degree angle. Now, one of the sides might be larger than the other, or they might be the same. We don't know if it's not marked, but we do know that the hypotenuse is the largest side. When we use the Pythagorean Theorem, as the directions ask us to do, it says state the Pythagorean Theorem. It says a squared plus b squared equals c squared. And I'm using lowercase letters for a, b, and c, which represent side lengths. A and b are lengths of the legs. I'll mark them like this with lowercase letters. We actually reserve uppercase letters for angles or vertices, so we're going to use lowercase letters to represent side lengths. I always like to go from smallest to largest if I can, if I have side lengths that have values, just so I know that smallest to largest, your largest side is always your hypotenuse, or c. Okay, what we're going to use, what are we going to use this for? We're going to need to state that we can use this to find the length of a leg if we know a hypotenuse length and another leg length, or we can use this to find the hypotenuse if we know the lengths of the two sides. So this represents the 2 out of 3 rule. The 2 out of 3 rule means if you have 2 out of 3 variables, you can solve for the third. So one more time, you can use this to find the length of the hypotenuse. If you have 2 legs, you can find the hypotenuse. Or if you have 1 leg and 1 hypotenuse, there's only 1, you could find the length of the last leg. And that's what you can find and use this for. Getting at the bottom, the first 2 exercises, exercise 1 and 2, says find the length of the missing leg. This is the 2 out of 3 rule. 6 and 8 are these lengths of the legs, are these 1 leg and 1 hypotenuse. Because these form the 90-degree angles, these are the legs. So we're going to call these A and B and find side length C. 6 squared plus 8 squared equals C squared. So we'll do 36 plus 64 equals c squared. If 100 equals c squared, c can either be plus or minus 10. However, because we're dealing with the length of a side of a triangle, then only the primary square root makes sense. We don't have units. Sometimes we do, sometimes we don't. So the length of c would be 10 units long. This is our answer. For exercise 2, we're given a leg and the hypotenuse. We don't know if this is the long side or the small side because pictures aren't accurately drawn all of the time for you. But we do know that it is one of the legs. So you can call it little a or little b, whichever one you like. A squared plus b squared equals c squared. A squared plus 81 equals 121. So why don't you go ahead and subtract 81 from both sides? We get 40. Square root 40. We have an irrational number. One more time, we don't need the negative sign in front of this because it represents a side length. What is the largest perfect square that goes in a 40? I think it might be a 4. The square root of 4 is 2, and the square root of 10 is the square root of 10. Since we don't know the units, we're just going to write the word units right next to that side length for its unit of measure. All right, this is the first couple of exercises. Let me go down to the bottom. We're going to introduce you to these 6 trigonometric ratios, of which you probably know 3 of them. You probably know how to pronounce sine, cosine, and tangent. And you may know an acronym for how to remember the ratios of these. So the sine of an angle, so we're given an angle. In a right triangle, the sine of an angle represents the ratio of the opposite side length divided by the hypotenuse length. We're going to mark our angle with this symbol. This is the Greek letter theta. And once you establish an angle, that establishes what sides are opposite and adjacent to this angle as a reference. You might remember this acronym. This acronym will help you a lot in this chapter. That was SOH-CAH-TOA. Sine is the ratio of opposite over hypotenuse, SOH. Cosine is the adjacent side divided by the hypotenuse, CAH. Tangent is opposite over adjacent, TOA. That's how you can remember these. Always, always, always put an angle that you're taking the sine, cosine, and tangent to because it's relative to where you're standing in the triangle. These three on the right are the reciprocals of these ratios. There isn't a sweet acronym like SOH-CAH-TOA for these that I'm aware of, but these represent cosecant, is what we call this one. The secant is the reciprocal of your cosine, so we call this secant. And cotangent is the reciprocal of tangent. COT is cotangent. So these are the reciprocals of the ones immediately to its left. How do you remember it? The sine has a reciprocal that begins with a C. The cosine that begins with a C has a reciprocal that begins with an S. So it's kind of like a little bit switched up and backwards, but that's easy to remember because it's consistent. And tangent and cotangent, these are the ones that are just kind of unique. So tangent and cotangent, if you see the T, you know that they go with each other. We're going to be using these a little bit later, maybe at the second part, and maybe these shortly. So let's turn to the next page. Well, that was fast. I turn to the next page. We are given a triangle with a marked angle, theta, up here. We have two side lengths, 5 and 15. And then it says evaluate the 6 trigonometric ratios. What we're going to do is we're going to, at first we need to probably find what this missing side length is, although we might be able to get one or two of these ratios already that are given to us. This theta is in the acute angle spot up here. We have this side length and that side length. I think 15 is going to be the hypotenuse because it is across from or opposite the 90-degree angle. And since the missing side length would be opposite, then this must be the adjacent side. So here's your adjacent side and your hypotenuse. This must be the opposite side. Now, which of these ratios uses adjacent and opposite, sine, cosine, or tangent? So, cosine, CAH, yep, that's it. So, CAH, so I'm going to do adjacent over hypotenuse, or 5 over 15. Now, we always need to have our answers be exact, rationalized denominators, and simplified fractions. This would equal 1/3. So the cosine of the angle theta is 1/3, which means its secant is 3 over 1, or just 3. So knowing one will help you get the other. These are the reciprocals that match or cross from it. Okay, next. To find the opposite side length, we're going to use that Pythagorean theorem. A squared plus b squared equals c squared. So let's do 5 squared plus, or let's call this little b. B squared equals 15 squared. 25 plus b squared equals 225. Why don't we go ahead and minus 25 for both sides? B squared equals 200. We're going to square root 200. Now b equals the square root of 200. The largest perfect square that goes into 200 is 100. The square root of 100 is 10. So we have 10 root 2. So the length of the opposite side is 10 root 2. So now we could do the sine. So SOH, O over H is 10 root 2 divided by 15. We need to simplify this. 2 root 2 over 3. What we're going to do next is we're going to do its reciprocal. Come back to this answer, flip it over upside down. 3 divided by 2 root 2. What's the problem with this answer? Well, our denominator isn't rationalized. Let's rationalize the denominator by multiplying by the square root of 2 over square root of 2. Simplify, we get 3 root 2 divided by 2 times square root of 2 squared, or 2 times 2 is 4. This is our cosecant for that angle, 3 root 2 over 4. Lastly, what we're going to do is find our tangent. TOA, tangent is opposite over adjacent, the opposite side divided by the adjacent side. 10 root 2 divided by 5, simplify would be 2 root 2. And if I take the reciprocal, this is 1 over 2 root 2. Rationalize this, I get square root of 2 divided by 4. These are your 6 trigonometric values for your angle theta. I'm going to stop the video because it is just about that time where I should stop the video, but we are still going to move on to our next sections, which I actually have filled out a little bit based on what we did in 9.0. All right.